We were looking at graphing in different squares, and we were talking about what each of the assumptions that we made regarding tastes imply about the shape of our indifferent squares. And we looked at what completeness implies, what transitivity implies, what monotonicity implies. We want to now look at what does convexity imply for the shape of our indifferent squares. So let's recall what convexity is. Convexity says that averages are at least as good as indifferent extremes. Again, in the case that we're looking at indifferent extremes. So for any two bundles that lie on the same IC, because you're indifferent between them, because bundles that lie on the same IC are those that are indifferent between them, those that give the same level of happiness. So what this says is that the convexity assumption says that if you have any two bundles that lie on the same IC, i.e. you're indifferent between them, the convex combination of these two bundles, the convex combination of the two bundles is just a weighted average of the two bundles, is at least as good as the original two bundles. And geometrically, the convex combination of any two bundles then be represented as a straight line joining them. So what convexity assumption is saying, okay, let's if we draw a RC like this, like we have two bundles that you're indifferent between, right? Like these two bundles. You're indifferent between them because they lie on the same IC. So now if you want, so now geometrically, we can represent weighted average of these two bundles, which we can also call as the convex combination of these two bundles as a straight line joining them, right? So it's like, oh, let's just draw it a little more properly. So we have these two bundles, and this is geometrically, and this line joining them represents geometrically uh, any weighted average of these two bundles or convex combination of these two bundles. So convexity says that any this a line which geometrically represents the convex combinations and weighted averages would be at least as good as the two extreme bundles. That's what convexity implies. So here the key thing is just to keep in mind how can we geometrically represent weighted average or convex combination of any two bundles geometrically as a straight line joining them, right? The straight line joining these two indifferent bundles will represent any weighted average or convex combination of the two bundles. That's a key thing to remember here. So now let's see, this was just recalling what convexity is and how geometrically we can represent convex combination of bundles. Now let's look at and let's see what does convexity property help determine. Now convexity property helps us determine the shape of our IC. What do we mean by that? Once we know that the IC is upward sloping, we already talked about this when you were looking at what does monotonicity implies that depending upon whether the commodities are goods or bads, we can determine whether IC would be upward sloping or downward sloping. Right. So once we've determined that IC is upward sloping, convexity will help us to determine, right? We know they're upward sloping, but is it upward sloping like this, or do we draw it upward sloping like this, or do we draw it like this, right? This is what convexity allows us to determine once you know that, say, based upon whether the commodities are goods or bads, that your IC is upward sloping. Now, will you draw it upward sloping like this, or like this? Similarly, if you knew based upon whether the commodities are goods or bads that the IC is downward sloping, now you still need to determine what the shape of the IC is going to be, which is what convexity will help you with. Okay, will you draw it downward sloping like this, or like this? This is what convexity helps us determine. So once you know whether your IC is upward sloping or downward sloping, what is going to be the precise shape of the IC? Now, what convexity property implies for shape of IC, it depends. Right? This is the key word here. What convexity property implies, whether when you know that it's upward sloping, which one of these will you draw will depend on the direction of increasing utility. This is extremely important. Whenever you're looking at what convexity implies for the shape of IC, you need to know the direction of increasing utility. We'll look at why this is important. Obviously, in the direction of increasing utility depends upon whether the commodities are goods or bads. Like we know, if both commodities are goods, then utility increases in this direction. If both commodities are bad, utility increases in this direction. If x1 is a good and x2 is a bad, if x1 is a good and x2 is a bad, then we know utility increases in this direction. If x1 is a bad and x2 is a good, then utility increases in this direction. Right, so it's very important that whenever you're using convexity to determine the exact shape of the IC, it depends upon in which direction utility increases. Now we'll look at why is this important. Now we'll just move on and we'll see that why is this important. So here we've discussed the convexity property helps us determine the shape of the IC. But what it implies with the shape of IC depends upon the direction of increasing utility, which in itself depends upon whether the commodities are goods or bads. So let's see. So we'll do 4 cases here and we'll understand this. Now first case is that both commodities are goods, right? These are commodities that the consumer likes. So we know we've already discussed this when you're looking at monotonicity, that when both commodities are goods, monotonicity is satisfied, and this implies IC is a downward sloping and utility increases in northeast direction. So this is very important. This is the Now we'll look at why is this important to keep in mind in which direction utility increases. Utility increases in northeast direction. Now, whether convexity is satisfied or not will help us determine. Now, we know IC is a downward sloping and utility increases in northeast direction. You can either draw it like this. This is also downward sloping, utility increasing in northeast direction. This is also downward sloping and utility increasing in northeast direction. So now what we already using the fact that both commodities are goods, we established two things. The IC will be downward sloping and utility will increase in northeast direction. The details of this one, the monotonicity related part. So now we know it's downward sloping and utility increases in northeast direction, but depending upon whether we assume convexity holds or not will allow us to determine should we draw it like this or should we draw it like this. Now, how will we decide this? Now, if convexity is satisfied, so we know averages are better than extreme, different extremes, right? We know over here, look at this. Let's take two bundles that lie on this IC. Right, they lie on the same IC, so you're indifferent between them. We know the weighted average, any weighted average of these two indifferent bundles, which is known as a convex combination, is geometrically represented as a straight line joining them, which we have plotted over here. Now, if convexity is satisfied, this line should be above the IC, right? In this case, utility increases in this direction. That's what's important to keep in mind. Utility increases in what direction? Here, utility increases in northeast direction. So if I draw my IC like this, so we know, okay, these are the two indifferent bundles, and then this line represents any weighted average or convex combination of these two bundles. So in this case, in this particular case, the way we have drawn it, averages are better than extreme because averages are lying above because any average of these two indifferent extreme, because if you pick any two indifferent extreme bundles in this IC, any weighted average of these two indifferent extreme bundles represented as geometrically as a straight line joining them will be above them, which in this case is in the direction of increasing utility. So they will provide you a higher level of utility, right? Because these bundles would actually lie on a higher IC, right? So they'll provide you more utility. So in this case, so if convexity is satisfied, your IC should be like this, because in this case, averages are better than extremes, right? Because we know, okay, if you pick any two indifferent extreme bundles on the IC, geometrically, the weighted average can be represented as this line. And in this case, we can clearly see, okay, since utility is increasing in the northeast direction, here averages are better than extremes. If I had plotted them like this, so we can see okay, for any two indifferent bundles, this line represents the weighted averages or the convex combinations. And in this case, because utility is increasing in the northeast direction, the indifferent bundles are actually preferred to this weighted average, right? Because utility is increasing in this direction, so they are actually preferred in different bundles to any weighted average. So this is why it's important to keep in mind in which direction utility increases, because we want to see whether averages are better than extremes or not. So if convexity is satisfied, in this case, we're assuming convexity holds, we'll draw ICs like this, because then if you take any two indifferent bundles, then the weighted averages, represented as the line segment joining them will be better than the indifferent extremes, again, because utility increases in this direction. Let's look at case 2. Now, case 2 is what if x1 is a bad and x2 is a good? Again, we have looked in detail in the monotonicity part that this would imply ICs will be upward sloping and utility increases in northwest direction. Now, whether convexity is now we know that IC is upward sloping and utility increases in northwest direction like this, right? But again, convexity will help us determine should you make it like this or should you make it like this, because both of them are upward sloping and in both cases utility increases in northwest direction. Again, let's see if if we assume convexity holds, then it should be plotted like this or should be plotted like this. Like now, again, if we take any two indifferent extreme bundles, in this case, we can see that the weighted average, which is represented by the line joining them, is actually preferred to the indifferent extreme bundles, right? Because in this case, we know utility is increasing in this direction, and in this direction, they're above the indifferent extreme bundles. In this case, if we have plotted it like this, then we know these are the different extreme bundles and any weighted average is represented as a line segment joining them. But in this case, we know utility increases in the northwest direction, and in this direction, the indifferent bundles are above the weighted averages, right? So in this case, averages are worse than extremes. That's what's important to keep in mind in which direction utility increases. Because utility is increasing in northwest direction, if we draw it like this, the averages are better than the indifferent extremes. But if we draw it like this, the indifferent extremes are better than averages because they're above them in the northwest direction. So that's what's important to keep in mind, where utility, in which direction utility increases when you're deciding what convexity implies. So if convexity is satisfied, we'll draw them like this, because in this case, then averages will be better than indifferent extremes. Now, if we look at case 3, case 3 is that now x1 is a good and x2 is a bad. Again, based upon what we looked in the monotonicity part, this will imply ICs will be upward sloping and utility increases in southeast direction. Right, so this is something that we know based upon whether commodities are goods or bads, whether IC slopes upwards or downwards, and what is the direction of increasing utility. Now whether convexity is satisfied or not will help us determine should we draw the upward sloping utility, upward sloping IC with utility increasing in southeast direction like this, or should we draw the upward sloping IC with utility increasing in southeast direction like this. Again, we'll look at, say, if we take any two indifferent extreme bundles like this. The weighted average is geometrically represented as a line joining them, and in this way, and in this case, as utility increases in southeast direction, we can see the weighted averages are preferred to the indifferent extremes, right? Because they're above the indifferent extremes in the southeast direction. So if convexity is satisfied, we should plot them like this. If we had plotted them like this, then you can see we could take any two in different extremes, and the weighted average is represented by line joining them. And in this case, we can clearly see the indifferent extremes are preferred, right? Because they're above the weighted averages in the southeast direction, right? So if convexity is satisfied, we'll draw them like this. And if you look at the last case now, where if x1 and x2 are both bad, so we've already looked at this in, So we've already looked at that this implies that ICs will be downward sloping. This is something we discussed in the monotonicity part, and utility increases in southeast west direction. So we know the downward sloping, utility increases in southwest direction, the downward sloping, utility increases in southwest direction. But now, depending upon whether convexity is satisfied or not, will determine whether we plot them like this or like this. If I make them like this and I take any two indifferent extreme bundles in IC, we know their weighted average or is represented geometrically as this line joining them. And we can see any weighted average in this case will be preferred, if we plot the IC like this, will be preferred to the indifferent extremes because they lie above the indifferent extremes in the southwest direction. So if convexity is satisfied, we will plot them like this. If we had made them like this, then these are the two indifferent extremes, right? Any weighted average is geometrically represented as this line joining them. And the way we've plotted in this case, because utility increases in the southwest direction, we can see the indifferent extremes would be preferred to the weighted averages, right? Because they lie because in this case utility increases in southwest direction, right? So over here, right, utility is increasing in this direction, so they lie in the direction of increasing utility as compared to the weighted averages, right? So basically, the key idea over here is that once we have determined, based upon whether the commodities are goods or bad, we can determine whether ICs would be upward sloping or downward sloping and what the direction of increasing utility is. Once you know that, to figure out precisely what the shape of the IC is now going to be, given that we know whether it's upward sloping or downward sloping and what the direction of increasing utility is, convexity helps us determine the shape of the IC. Right, and in that, always keep in mind with the direction of increasing utility is, right? Because over here, direction of increasing utility tells us the way we've drawn it, the averages are better than extremes, and the direction increasing utility tells us here extremes are better than averages, right? So you have to be very careful whenever you're looking at whatever convexity implies for the shape of IC, you need to see what the direction of increasing utility is. So last assumption is the continuity assumption. What does this imply for ICs? In terms of ICs, now this simply implies continuous preferences imply we have continuous curves with no sudden jumps or spikes, right? So we're going to plot continuous curves and then we're going to be no sudden jumps. So we looked at what each of the 5 properties imply in terms shape of our ICs.